Hi everyone, today I'm going to show you how to use Python pandas to read time series data. The goal of this tutorial is to understand some basic but useful functions of pandas. Let's look at the data file. It is called one_self.csv. The data comes from ESA, European Space Agency, and it's from the satellite Mars Express, which flying around the Mars. So you can get the data from this link. If you click this link, you will go to this website and you can download the file. In this tutorial, I only use one file of the datasets. I just changed the file name to one_self.csv. The data is sensor data from August 2009 to July 2010. It is 1 Mars year data. It records the solar aspect angles. The first column, UTMS, is a timestamp. The SA column is the solar aspect angle of Mars Express solar panels normal. SX, SY, SZ are the solar angles of the corresponding axis of the satellite. So the most important is the SA column. Now let's have an overview of this tutorial. We will at first import some necessary packages, then read the data, and then convert the value of timestamp column from integer to data time type. After that, we will plot the data, then downsample the data and smoothing the data. At the end, we will find a gap of the time series. This is all the process of this tutorial. Now, let's import some necessary packages. The first line, matplotlib inline, means I want to plot images in the JupyterLab. Then I will use 3 packages: matplotlib for plot image, pandas, and numpy for data analysis. Now let's go to the read data part. Read data, we use this read CSV, PD pandas read CSV, and we give the file name. It is this file, one is AAF.csv. Of course, you can also give some delimiter, for example, it's a comma or whatever. In our case, it's a comma, and here is the help of the function. This is why I like JupyterLab so much. You can see it directly, and we can say, well, let's see how the data looks like. Yes, we see the data set here. Now we have a question: how many rows has the data set? So it's such easy. Shape. So we will see it has 1.2 million data set, 1.2 million rows. We want to know also the missing data, whether the data set has missing data. So it's actually has isNA. So isNA will, let's take a look. What's this? It will tell you which position is missing. If it's not missing, then it's false. If it's missing, then it's true. So how can I count how many missing data in the data frame? We can do it in this way. So see, there is no missing data in this data frame. So let's explain this code. df is just write down which position is missing. Then show it here, show it in the df data frame, and then I add all the missing data together. So true is 1, false is 0. So let's sum it. Then we will see there is no missing data in this data frame. It is nice features for us. The next step, we want to convert the timestamp to data time object, because this kind of data is very difficult to read. Also with data time object, we can also easily to add or the minus, do some calendar, add or the plus is more easier. So use pandas, it is very easy to do that. Just do we create a column called tm. Then use this function So let's see. Yes, I create here a column called tm, and use this to convert this column to data time objects. So I will get this data frame. Now what I want to do is I want to remove this part. I want to remove the UTMS column. So no, it's wrong. So I need to write it as the axis is 1. It means the column. So let's do it again. Yeah, this is the data set what we want to have. Now we can plot the data set. Let's take a look how the data set is. Use pandas is so simple, just a plot. Then I can define what's the x. X is tm, and y is equal to, you can choose some y as a sx or something like this, but since we plot all the columns, we don't need to specify it. So let's see. But we will see it's very long. It costs a lot of time. It's definitely not something you want to plot or you want to see, because so large data set, you cannot see anything, isn't it? Let's see. Let's wait for the result. Finally, the data come. But it is not what we want to see, isn't it? We can see nothing from this build. Okay, the things we have to do is downsample the data to make the data a little smaller. How to downsample the data? Let's downsample the data today. So we see here our data is corrected by every seconds. It is from 2008 August to 2010 July. So we can do this. Resample. See, if we write resample, we will see the explanation here. Here we need to give the rule. We give it D. That means we downsample on day, on the column TM. Then we use mean value of the day. So we can do df plot. It is much faster. It is nice. So if you want to the picture a little larger, you can do this. You can give it this 10. This is a figure size. You can set it to 1010. Then it will be a little larger. Let's check the downsampled new data. How many rows? Shape. So we see we get 687 rows and 4 columns. Now let's make this time series data more smooth. You can simply use the function day moving average rolling. We use the function rolling, and the rolling we need to set the window. Usually we can, for example, we can set it to 10 days. It means we average the 10 days to the mean value, and so it will be smooth. We can take a look at this data. Yes, it's more smooth. And what it happened if we put it 20? Yeah, it's much more smooth. Or what if we put it 5? Yeah, it's more zigzag. What is to we put it 30? So you see, it's more smooth. So here we can also use other functions, not necessarily mean. You can also use standard deviation, for example, this one. So you will see, maybe we put the 10, maybe 5. Okay. We can see here will be standard deviation very large, here will be smaller. But anyway, we can use it here, mean. This is moving average. It's similar. We see here is a gap in the time series. It is obviously an anomaly. We need to ask the experts what happened in this time. So to detect such a gap automatically, we need to define the property of this kind of gap. For example, we can say if the data don't change for a long time, then it is an anomaly. So we can set the standard deviation as a measurement. If in a certain time interval, the variance of the data are smaller than a certain level, then we can call it an anomaly. Now, let's write a function to examine a gap. It is called getStd. It takes two arguments. The first one is ARR. It is an array, which represents the value of the days. The second is thresh. It is the threshold of the standard deviation. If the deviation of all the days are smaller than the given threshold, then it is a gap. Return 1, otherwise 0. Let's test the function. Assume we have a 5 days data as an array. Put it in this function, threshold equal to 2. Then it returns 0, not a gap. But when we set the threshold as 20, then it returns 1. It is a gap. So correct. Now we can detect the gap. We use the rolling function to get the smoothed data, and then apply the ag function, aggregation, which let getStd function apply on all the time series to detect the gap. Then we use the plot function to plot the result. 0 means normal, 1 means gap. Here, we're only interested in the SA column. It is the most important feature according to the data description. We saw the bug between the end of November and the end of December. It is correct according to our observation. Now let me explain the code. In the rolling function, we put window equal to 5 to make the data based on the every 5 days window. Then the aggregation function will be applied on the resulted data. Our getStd function is as argument passed to the aggregation function. The first argument array of the getStd is automatically given by the rolling function. The second argument, thresh, we can simply write it behind the getStd function. Now let's check which days are the gap days. The first day is November 21, 2008. The last day is December 20, 2008. Now let's check how long is the gap. It is 30 days. The bug is 30 days long. Okay, this is the content for today. Hope it can give you a basic image about how to use pandas on time series data. See you next time.